Yes, sir.
Okay. So with relations and functions. Today I'm going to find topics. Carries 8 marks combinedly chapter 1 and 2.
माइक बंद कर.
Hello. Okay. Relations and functions. What is first of all a relation? Of course, when I ask the question, I myself have to answer because I cannot wait for your answer. A relation is a subset of A cross B, or any subset of A cross B is a relation from A to B. What is A cross B? A cross B is the set of all ordered pairs X, Y, where X is from A and Y is from B. If we take up set of all ordered pairs, that is X, A cross B, any subset of that is a relation. For example, or we write a relation from A to B, or from A to B. AB is a member of the relation. If AB is a member of the relation, we write A or B, or we interpret this as A related to B under the relation. When AB is a member of R, we write A or B. What we mean by that is A is related to B under the relation. So for example, let us take some simple examples. When A is 1, 2, 3, 4, B is 5, 6, 7, 8, 9, 10, what is A cross B? 1, 6, 1, 7, 1, 8, 1, 9, 1, 10, 2, 5, 2, 6, 2, 7. Okay, that goes up to 4, 10. That is A cross B. How many elements in A cross B here? Here it is 4, here it is 6. For 6 or 24 elements will be there in A cross B. Okay, if A has M element, A cross B will have Mn elements. Mn elements. Okay. Some join. Okay. All right.
Yes, sir.
Okay. Okay. Now let us take a relation R from A to B R equal to 162848. 162848 is very much a subset of A cross B, and hence it is a relation. Here 16 is a member of R, so 1 related to 6. 28 is a member of R, so 2 related to 8. Okay. Further, 4 related to 8. Another example, if you have 1, 6, 2, 7, 2, 8, 8, 3, 10. It is very much a subset of A cross B. That is also a relation to A. 1, 6 member of R, so 1 related to 6. 2, 7 member of R, so 2 related to 7, and so on. Well, again we can have 110. 110 is not a member of R because the R doesn't have 110. So 1 is not related to 10. 1 is not related to 10. One more example. So many examples. 2, 5, 2, 9, 3, 5, 2, 5, 2, 9, 3, 5, 4, 5, 4, 8, 4, 10. These are some examples for a relation. So ultimately, what is a relation from A to B? It is a subset of A cross B. It is a subset of A cross B relation. Here 2 related to 5, 2 related to 9, and so on. Well, can you answer me? If A has M elements, B has N elements, how many relations are possible from A to B? A has M elements, B has N elements. How many relations are possible from A to B? I refer to some results which you have. If a set of elements, then how many A can? If number of A is M, then the number of subsets of A will be 2 raised to M. If A has 3 elements, it has 2 cubed, 8 subsets. If A has 4 elements, it has 2 raised to 4, 16 subsets. So now look at from A to B, it is a subset of A cross B. Subset of A cross B. A cross B will have Mn elements. A cross B will have, here A cross B has Mn elements. The number of A is M, number of B is N. The number of subsets of A cross B will be 2 raised to mn. The number of possible relation from A to B is 2 raised to mn. Can you store in your mind? A has m elements, B has n elements. The number of possible relation from A to B is 2 to the power mn. Can you answer this question? If A is 1, 3, 5, B is 1, 2, 3, 4, how many relations are possible from A to B? Can one of you answer? Kushti, can you answer me? A is 1, 3, 5, B is 1, 2, 3, 4.
128.
How much?
128.
Are you sure? 2 to the power mn. What is your mn?
12, 3 and the power
So
12.
what is the
2 raised to power 12.
big number? Yeah. 2 raised to 12. We can calculate. So number of A is 3, number of B is 4, number of A cross B is 12. So from A to B, you will have 2 raised to 12. Subset 2 raised to 10 is 1024 to be 4096. The domain, if you pick up the second component, set of all second components, that range, and the A from A to B, from A to B is a relation, B itself is the codomain. For example, suppose I have A is equal to 1, 2, 3, 4, B is equal to 5, 6, 7, 8, 9, 10. I'm giving offhand a relation 2, 5, 2, 9, 3, 5, 4, 5, 4, 8, 4, 10. What will be the domain? Obvious. 2, 3, 4 is the domain, and what is the range? 5, 8, 9, 10. 5, 8, 9, 10 is the range, and what is the codomain? It is B itself, because if a relation from A to B, the codomain is B. So the domain is the collection of first components, the range is the collection of second components, and codomain is B. Far from A to B is the relation, then B is the codomain. Domain, codomain. One more. R from A, xy such that y is equal to 3x plus 1. Here, when I list R, I'm getting 2, 7, 3, 10. The domain is 2, 3. Range is 7, 10. And codomain is B itself. Set of all xy where y equal to 3x plus 1. When 3x plus 1, when x is 1, 3 plus 1, 4 is not there. Don't worry. When x is 2, 3 to the 6 plus 1, 7. So 2, 7. When x is 3, 3 to the 3 to the 9 plus 1, 10. And when x is 4, there is no element. So only 2, 7 and 3, 10. So the domain is 2, 3. Range is 7, 10 and codomain. Now inverse function, inverse relation. What is inverse relation? If R from A to B is a relation, the inverse of R is the relation from B to A, denoted by R inverse. We call it R inverse, not R is to minus 1, R inverse. Defined as R inverse from B to A, R inverse equal to set of BA, so that AB is a member of R. That means whenever AB is a member of R, we pick up all the reverse ordered pair. We flip the order of the ordered pair, we get R inverse. The inverse relation. A is from A, if R is from A to B, inverse will be from B to A. Is simply flip the order of the ordered pairs in R, we get R inverse. For example, A is equal to 1, 2, 3, 4, B is 5, 6, 7, 8, 9, 10. I'm just supplying a relation R 2, 5, 2, 9, 3, 5, 4, 5, 4, 8, 4, 10. What will be R inverse? R inverse will be from B to A. R inverse will be 5, 2, 9, 2, 5, 3, 5, 4, 8, 4, and 10, 4. That is the inverse relation. Nothing more. We flip the order. You have 2, 5 member of R. then 5, 2 will be member of R inverse. 2, 9 is a member of R, 9, 2, and so on. R inverse, if R is from A to B, R inverse will be from E to A. Now when I say relation on a set, remember relation on a set, it is simply from A to B, A to A, A to A, or it is a subset of A cross A. Relation, when I say relation on a set A, that means it is from A to A, or it is a subset of A cross A. If R is a relation on a set A, we write it R from A to A, and that we call on a set A. Well, how many relations possible? If number of A is equal to N, number of A is equal to N, the number of possible relation on A will be 2 raised to N into N. That is 2 to the power N squared. 2 to the power N squared. Because if it is from A to B, number of A is M, number of B is N, the number of relation will be 2 raised to Mn. Here, if number of A is N, the number of possible relation on A is N squared. We go for now some type of relations. Are you getting along? We have discussed what is relation, what is inverse relation, what is the domain, what is the range, what is a codomain. The notations are very clear. Null relation, also known as empty relation or known as void relation. There is no element. The null set or empty set phi is called a null relation or empty relation or void. Of course, relation is a subset of A cross B or A cross A. A subset can have no element also. For example, let A is equal to 2, 3, 4, 5. I define a relation R from A to A. R equal to set of X, Y such that Y equal to X cube. Is a null relation because there is no element. We cannot have any element in Y equal to X cube. If X, Y is such that Y equal to X cube, there is no element. And it is a null relation because R contains no element. It is a null set. That is a null relation or empty relation. Now we go for universal relation. Obviously, universal relation is the set across A itself. Because when you take up the subset of any set, the same set itself is a subset, very much a subset. So across A, when I say across A itself is a relation from A to A. It contains all possible elements. I'm taking only A here. Suppose A is equal to 2, 3, 4, 5. If I have a relation from A to A, R equal to set of X, Y such that X plus Y less than 11. What are the elements here? It is a subset of A cross A. 2, 2. Yeah, 2 plus 2 less than 11. 2, 3. 2 plus 3 less than 11. 2. 2, 4. 2, 5. 3, 2. 3, 3. 3, 4. 3, 5. 4, 2. 4, 3. 4, 4. 5, 2. 5, 3. 5, 4. 11 is true for all X and Y. So here when I say list R, R is 2, 2, 2, 3, 2, 4, 2, 5, dot, dot, dot. I don't list all this. It goes up to 5, 5, which is across A itself. So across A is a universal relation. We have a null relation. We have a universal relation. Further, we have identity relation. What is an identity relation? Defined on a set A in which every element of A is related to the same element of A is called an identity relation defined on. In identity relation, every element will be related to the same element only, nothing more. If A is equal to 1, 2, 3, 4, IA of, for example, let us take A is equal to 3, 4, 5, 7. R from A to A, R equal to set of X, Y, such that X is a factor of Y. R is an identity relation. Why? If I look for the relation R, it consists of the elements 3, 3, 4, 4, 5, 5, and 7, 7. Is there any other element in this relation? no other element. This is an identity relation. Identity relation can have a special notation IA. The suffix A denote on which set that is defined. If I have a set B which consists of one more element, it may not be an identity relation on that because this consists of 3, 3, 4, 4, 5, 5, 7, 7. IA has only responsibility of members of A to have the same element, same image, 3, 3, 4, 4, 5, 5, and 7, 7. Identity relation. So the three kind of relation, one is null relation, that is containing no element, universal which contains all possible elements, which contains universal relation which is containing all possible elements. Identity relation is a relation defined on set. Every element of A is related to the same element of A, and we denote by IA relation, identity relation. Okay, example here. Well, are you getting along? We have defined relation. It is actually a revisional topic. We have the domain, range, codomain. Further, we know how to list the elements of a relation. You can revise from your 11th topic, but that is not a matter. We are going ahead with the topics. I will define everything what is required. Further, we are going with the type of relations. First, we have null relation, that is empty relation. We have universal relation, which contains all the elements. We have identity relation. Can you note down for a few questions? Let A is equal to 1, 6. B is equal to 1, 2, 3, 4, 5, 6, 7, 8. I want a relation from A to B. R is equal to set of x, y, where x plus y more than 11. You have to list R and you have to write the domain and range of R. Second question, R1, another notation. From the same set A to B, where R1 I am defining set of x, y such that mod x minus 3. Can you list the elements of R1 again? Okay, getting along? Contained by this, we have the relation. Now the type of relation, we go ahead. What we discussed till now was a revisional topic. From tomorrow, we have to start new points which we have not covered in 11.